Hi everyone, welcome to the course of Machine Learning for Electrical Engineering. So machine learning is not a new field for electrical engineering. What you know is adaptive control is one of the things that is known as machine learning. So before starting, I just want to let you know that machine learning is very useful for electrical engineers. Say for example, it can be used for load forecasting. It can be used for so many simulations. It can also be used for state estimation, or it can also be used for fault detection. The best example you know is a Kalman filter, where you estimate state of any variable with time. If you talk about fault detection, then you can see that suppose you want your output at set point, which is the main objective of any control or any engineer, then your output should be at set point. But if it deviates from that point, or it has oscillation, or it has maybe variance, then you have to figure out that. That is known as fault detection. The other examples includes generating energy data for machine learning using recurrent generative adversarial network. You can also do feature recognition from piping and instrumentation diagram using machine learning. Also, if I talk about you can identify the mobility of electrons with the change in density of a material. You can also do electrical load data compression, or you can also use empirical mode decomposition for finding wind speed and wind power prediction. Or if suppose you start with load forecasting, or you are able to identify what is the load in future, you can do predictive analytics, you can do predictive maintenance. And if you see all signal processing in electrical and electronic engineering, that is also a part of machine learning. Before starting, I just want to tell you that how machine learning or how AI is using data science. So if you start AI is the big umbrella that encompasses machine learning, or you can say deep learning and reinforcement learning. All the three fields uses statistical techniques or uses data science to come to a conclusion. So in this lecture, which is all about introduction to data science, we will talk about basically how we can approach a machine learning problem, or how can we approach a problem and solve it using just the data. So I'll just want to introduce what are the learning objectives you will get from this course. We will introduce Python for data science and machine learning. We are using Python because Python is a freeware and it can be downloaded easily, as well as it has a large community where you can post your question while you are solving a problem using data, or you're designing an algorithm for machine learning, and you'll get your replies as soon as possible. Then we'll introduce cutting-edge machine learning algorithms that will help you understand the field of machine learning, how you can approach a problem, and then we'll introduce assignments and case studies to provide application perspective for techniques learned. Then, what outcomes you will get from this course? You will learn how to describe a flow process for machine learning problems, and then you can classify machine learning problems into standard topology. We will also develop codes for machine learning solutions. We will also correlate results to the solution approach followed. We'll get an approach where we can assess the solution approach followed to solve any problem using data science and machine learning. Then the first question is, what is data science? And then the next question that triggers to your mind is, why do we need data science? Because data is the fuel nowadays. Now, if you see, whatever you do, you are giving data to the server. Let's talk with an example, like you go surf on the net, use your social networking site like Facebook, WhatsApp, Twitter, then that all the data goes into the server, people can use it and exploit it and will give you some recommendations. Since data is the fuel for everything now, or you can say for machine learning, then you can use data to explore things. You can use it for recommendations and you will become a storyteller. Now, with the help of data, you can have meaningful insights, or you can draw meaningful insights from the data. Now, why data science is a buzzword? Now, data science is a science that is used to make sense out of data and can be used to comment on data, which can be applied on data, and we can give a lot of meanings or sense of data. So, we'll talk about data more. Like, data science can be used to exploit data to do predictive analysis. Other thing is why everyone talks about big data. Because if you talk about in the previous days, we don't have sources to record data, to store the data. Now we have servers. Now we have techniques where we can compress data and store the data. Or you can say the storage capacity increased nowadays. So data is being collected from most of the sources in this real world. Say for example, you go for booking a ticket, or you use an app booking a ticket like GoIbibo. Wherever you search for a flight, the details is recorded in the servers. Suppose you miss to book a flight and you decided to book a flight a day after, then what will happen is people sitting behind the screen, or the people who are working for data scientists for GoIbibo, they will use that data and try to recommend you what flight you can take and what are the discounts. Basically, if we talk what is data science is the branch of science that uses available statistical tools to analyze data. Like you can say, for example, correlation approach, like probability, and so many other things. These statistical tools helps to infer about the data and help to draw conclusion about the process. So statistical tools like mean, variance, or mode, these are some tools that helps you to understand what is data is all about. Now, since we have large amount of data or big data, we can use it for training our machine learning models, and we can do forecasting, or we can do predictive analytics, or we can suggest or comment results based on that. Now, some of the data science applications are, or you can say that data science is used in all the fields, and it's a very good recommendation for all the electrical engineer that they should not stick to electrical engineering applications. They can explore other applications, because if they go for a job anywhere, they should not be restricted towards electrical engineering. They can be like universal in all the sectors, and they can apply as a data scientist or data engineer to get a job in any of the field they like, or where is opening is there. So let's talk about use of data science in financial, or use of machine learning in financial sector. So financial sectors like banks are using machine learning and data science for predictive analytics, like to whom they should give a loan and or to whom they should not give a loan, or they can identify the credit defaulters who takes the loan will and not pay the loan. So it's better to predict beforehand and should not give loan to the people who are not going to, or those who are not willing to pay the loan. So next is Google Maps. If Google Maps are not there, then it's very tough to travel from one place to another for people who don't know the city. So Google Maps keep on tracking your data from your mobile, and it keeps on updating, keeps on giving you the current details about the routes, which route is better for you, which route is shortest for you, or which route you can take where the crowd is very less. How it identify the crowd is less or more? If it takes data from all the mobiles, if it feels like the data is coming from more number of mobiles, that it feels like it's a place is very crowded. Also, data science and machine learning are used for digital advertisements. It can be used for advertisements of, like, you can identify the prospect customers to whom you can send that advertisement. Suppose, for example, if you go to YouTube and you're watching some video, then the next recommendations comes or ad comes related to that video. So they are identifying their customers and they are identifying what ad or what advertisement they should give to make money or to sell that product or anything like that. So now, previously if you see Facebook, there what happens is you need to tag your friends if you want to tag your friends in a Facebook. Now, what is now happening is it's become automatic friend tagging. Now you see that if you trying to post a photo and writing some text about it, it will automatically tag your friends. If you want it to be done, you say it okay. If not, then you can cancel it. Now, other thing is like Flipkart or like Amazon or like e-commerce company is using delivery logistic optimization of routes for their delivery boys so that they can deliver the product in less time, as well as they can identify the best route so that they can reach their place where they want to deliver their products. Also, it can be used for product recommendation. Like for example, if say assume yourself as a Google Play Store, where what happened is you are trying to recommend an app, assume app as a product. Right now, you're trying to recommend some apps to the user based on your data, based on your understanding. Say for example, you have people with different sex and different ages. So you try to analyze previous data, or you can identify the data properly, or you can train your model where you can see that like what is the previous trend. Like say for example, some people are using WhatsApp, some people are using Snapchat, some people are using YouTube. So say for example, you are trying to figure out who are the people who are using YouTube, who are the people who are using WhatsApp, and who are the people who are using Snapchat. So you are trying to train your model based on some of the features like male, female, and age. With the help of that, you can identify what is your prospect recommendation that goes after once you train your model. Now, if you talk about more about marketing, you can do customer segmentation. If you talk about customer segmentation, like for example, I want to give an example, like you have given like credit cards to some population. Now, some of the population or some of the people are using credit card that uses, whenever they do transaction, they use a high amount value, as well as their use for credit card is very frequent. And some people are there who is using credit card, and whenever they do transaction, they use a very high amount, but their frequency of using is very low. Some people or some part of the population is there where they use, like for example, they use credit card for very low amount of value, as well as the frequency of their usage is very low. So now here what you're going to do, you have to figure out all the three kinds of people. There you can use clustering approach to figure out which group of people are doing which kind of transactions. And this is customer segmentation. This is one of the example. Now, if you talk about more like predicting churns, which is like, say for example, this happens like when you are trying to look data for telecom industry, where people have churned out from one like telecom operator, like say for example Jio. Why they have churned out, you have to figure out those reason, everything with the help of data. Now we'll talk about what problem we have at hand. Like in general, what happen is we have a large variety of data which is available for use. Even we also have large variety of tools that are available. So we don't know which data to use, which technique to use. This is the problem we have in our hand. Or we sometimes think that, are we ready to solve a problem? Because all that is a mess. How do we solve the problem is the question we have to ask from ourselves every time. The next objective is to understand what we want to achieve. So the problems, if you see this image like here, it's a problem of puzzle. So you have pieces of puzzle, you have to arrange the puzzle properly, and you have to come up with that one conclusion. Now again, you have to understand that how the puzzle is going to look after it gets solved. That is the best notion you should have in your mind, because if you don't have that notion, it is very tough to solve a problem. Now, I can say that how you can approach a problem. What you can do is, suppose you have a big amount of data, then you have to understand what piece of data you have to use for, what piece of data you have to ignore. So what is the important piece of data you have to acquire for building a machine learning model, and then what piece of data you are going to do prediction for. The next is like you have to remove the unwanted piece of information which you don't want it for your model to get trained it for, and you have to focus on all the important one or important piece of data for which you have to build your model. Now what happened is, once you have your data with you, what you have to do is, now other question comes in your mind is you have to concentrate on right methodologies, because if you see in this world a large number of machine learning techniques exist. Like if you see, for example, supervised, unsupervised reinforcement learning, a lot of techniques exist. And even if you go into supervised machine learning, you have a lot more algorithms. If you go into unsupervised learning, you have a lot more algorithms. So you have to understand which technique to use for. The other things in your mind should be there, like, is the data clean? If not clean, then you have to look for approaches how to clean the data. And once you clean the data, that's one thing you can do it. But before that, do you have the domain knowledge about the data? Do you have data, metadata for the data? Do you have any information about the data? Once you have data and information about the data, then what you can do is you can tweak existing methods, or you can build a method first and then you can tweak that method to get your desired results, or whenever it is required. Now I'll talk about like why we are using Python for data science. The question is like why we are using Python, why we are not using Java, why we are not using MATLAB, Octave, Scala, Julia, Lua and others. So if you see in US, Europe, Japan, China, everyone is using Python, or you can say Python dominates over R, Java, MATLAB, Octave, Scala, Julia, Lua and others. 7% of the people of the total population in US, Europe, Japan and China is using Python. Now if we move into the scenario in India, what is there is, now like 44% of the people are using Python. And if you see some 5 years back, R was dominant, but now Python has dominated over R, SQL, SAS, MATLAB and other. Python and R both are freeware, but MATLAB is not a freeware. So, and as I told you before, Python has a large community where you can get your answer or resolution faster as compared to R, SQL, SAS, MATLAB and other. And MATLAB, you have to get license and everything for that, and that is a little complicated. Now we will see that what is going to happen in future, which programming language is going to get vanish in future, like do you going to adopt or migrate to other language in next 12 months or not. 51% chance is like you're not going to migrate from Python, because Python it has a very fast growing community, as well as it has a large number of packages, libraries and everything. And the very less chance that you can move into C++, that is 15%, and then you have 13% you can go for Go and Kotlin, and 7% chances are there you can going to move to R. So if I talk about like what is the opinion you have, what programming language is the most used for data science in the next 5 years, is that I can guarantee you that like Python is going to dominate for the next 5 years. Now I'll introduce about Python more, because we are going to do everything in Python using Spider and Jupyter. So Python was developed by Guido van Rossum in the late 80s at National Research Institute for Mathematics and Computer Science at Netherlands. It is an open source and community development under open source initiative approved by license, making it free to use and distribute even commercially. And it has a very big community. I keep on repeating big community because so that you can get very familiar with Python and you can get your resolution faster. It has very simple syntax, as well as it has a large number of libraries, and it has libraries for specific data science tasks. So commonly used IDEs are Spider, PyCharm, Atom, Jupyter Notebook, etc. So before we start with Python, it is better you should not directly go to Python 2.7 or 3.7 something. You can install Spider for learning and install Python going into this link. The link will be shared to you all guys, and even I can tell you how you are going to approach and how you're going to download your Anaconda. Now which version to choose is like, right, we have a version like Anaconda 3. We have to use Anaconda 3. I'm not going to use Anaconda 2, because if you're going to use Anaconda 2, then you have a Python inbuilt as Python 2.6 or 7, and if you are going to use Anaconda 3, there you will have Python 3, 3.7. so you can choose any of these like executable files. So I'll show you through how you're going to approach it, like how you're going to download it. So you can click on the version to download. After post download, you have to run the setup. If you're downloading in Windows, if you're downloading in Mac, you have to run using your command prompts and everything. If you're doing in Linux, then what you have to do is you have to use your terminal, and you have to make it sure that you have to write some line of codes to download Anaconda 3 in your Linux operating system. Now you have to set the path, and you have to open Anaconda Navigator. Once you open your Anaconda Navigator, you will see that, talking about Windows, I'm not going into like Linux and Mac operating system, so I'll be sticking to Windows. So make sure that you don't get confused, I'm using Linux or I'm using Mac. So make sure that you will also have Windows, so that you can understand how to do things. So like you see that Spider is here. You can click on launch button to launch Spider window. I'll keep on interchanging between Jupyter and Spider, so that you guys can learn Jupyter as well as Spider, and you can easily work on Jupyter and Spider, because most of the machine learning community, most of the people who are doing machine learning uses Jupyter for their all of your machine learning training and testing. So next is like, once you launch it, how Spider is going to look like is, you have some windows, like you have a script window here. Here you have windows where you can explore variables, you can explore file, you can have a file explorer, you can have help, and here is the console, or is the command window where you can type your commands directly to execute it. Then that's what I said, is this is the script window, and here you can see files, variable explorer, help and all. This is your console. So now how we are going to set working directly for us? There are three ways to do it. The one way is to go to the symbol to choose a working directly and click on the icon. Once you click on the icon, wherever you want to go, where you want to set your working directly, go to that location and click open. The next thing is like, you can use your console and type like import OS, which is one of the library in Python, and then you can use OS CHDIR, and whatever the directory you wanted, just write that directory name and press enter. Or you can do it from terminal using cd c something c colon backslash user backslash del backslash desktop, like whatever location you want to go with. Now how the file explorer looks like. If you click on file explorer, here you can click and you can see what other files are stored or saved in this folder in your setting, in your working directory. Now what you learned in this is, you learned about the interface of Spider, how Spider looks like, and you understand how you are going to set up your work directory, and then you can understand how you are going to access your file explorer. So this is all about like presentation. Now we are going to see how we are going to work in real time. Now first I'll start with installation guide of Anaconda. Go to your Google Chrome and type Anaconda repository and click enter. Now click on Anaconda distribution repository and go to Anaconda installer and click on view all installers. There you have to see Anaconda 3.5.3.1. You have to download Anaconda 3 5.3.0 Windows x86 64-bit. Click on download. Once it's downloaded, go to your file explorer where you have downloaded and then click on that installer. Once you install it, open your search window and type Anaconda Navigator. Click on Anaconda Navigator and you will see this window. Now here you can launch Jupyter, you can launch Spider, or you can either install R for your reference and then you can use R as well. From this window, come to Spider and click on Launch. After launching, you will see Spider started. Getting into the Spider, first is we should learn how Spider is. I have already told you about setting up the directory. How you're going to set the directory, like you go there in the Windows folder icon, click on the folder icon. Say for example you're going to set your directory like E directory. Click on anything where whatever you want and then set that as a folder. Or you can do like using command prompt, or you can just do it on a console. Type import. While importing, import that library OS. Now you can write os.chdr and then in your double quotes you can write whatever directory you want to make it as a working directory. Like for example, you want the directory which is E is Skill-Lync Machine Learning for Electrical Engineer Week 1 as a work directory. You can write this destination folder name and press enter. Or the other way you can do is you can go to your command prompt and write cd e /skill_link machine learning for electrical engineering week 1. This is how you're going to set your working directory. Now you will see here like nothing is there in the variable explorer as we have not worked on anything, but if you go into file explorer you will see files like challenges1.doc, challenges1.pdf, data science and programming language.ppdx and project1.py is there in this folder. Now what you can see is like what else it can be done. I'll tell you here how you're going to. So before getting into it, like how you're going to clean your variable explorer and how you're going to clean your console, you can clean your console by giving a command like clear. This will clear your console, or you can do it also by using %clear. That will also clear your console. The next is like you can see, since a thing is there in a variable explorer, so let's start with creating something in the variable explorer. Say for example a equals to 10 and b equals to 5. So we are having some integer values are a and b, and c equals to a plus b. So we have now 3 variables in our variable explorer. Now we can see how we are going to clear this. So there are several ways to clear this. Is we can use our command called reset to clear the explorer. It will ask for you whether you want to clear it because it cannot be recovered. Then if you want yes, you can do it by typing yes. If no, then you can type as no. Now we'll see the second way how we are going to clear our explorer for variables. See, now the other way you can do it by just directly going, you can see the eraser option here, and you can just click on it. It will ask for you whether you really want to clean it or not. You can press yes to clean it. So other thing, like how you're going to save your data. If you want to save data, then you can do it by you can click here, save data, or if you want to save data as .mat file, you can click on save data as, and you can save data as .mat file or in the format in which you can work with Python. So this is about how you're going to work in Spider. Now we're going to see how we are going to work on Jupyter.